All right. Today we're going to briefly discuss the concept of electricity. We're going to cover Ohm's law, resistors in parallel and series. So now I want this video to be very short. Now, when we look at this setup I have here, this is what we call a circuit diagram, where these two lines, represent the source of EMF, all right, or source of voltage, which can come from the battery. And one thing you must know is that this longer side, all right, is not just longer for no reason. The longer side is the positive side, while the shorter side is the negative side of the cell or the battery. And you know that conventional current will always flow from the positive to the negative, all right? So the positive side is going to have a higher potential difference than the negative side. So if that is the case, it means that electric current is going to flow in this direction. Now, Ohm's law Ohm's law is a simple combination of three things actually in a circuit. For every circuit, it will have many components, but at the basic, it's going to have three components, and we can also use it to relate different types of conductors. So what's Ohm's law saying? Now, I will call this source of EMF V, all right? Ohm's law is saying that given that you have a source of EMF V, right? This EMF, I want you to continue to see it as a force. See this as a force, right? All these lines I've drawn here represent the wire or the conductor through which the electric current is going to flow. So see this EMF or the source of voltage as the force that pushes electrons through the wire. All right, because if you remove a battery from any cell, there's not going to be any electricity because the electrons need a force to push them along the battery. So what provides that force is the battery or the EMF. That's why they call it electromotive force, electron moving force. It is the force that moves electron. Now you notice that since the electricity is going to flow through the positive terminal, this kind of a rectangle here represents a resistor. That's the symbol for a resistor R. It's going to flow through that resistor R. And what's a resistor? A resistor is a component that opposes the flow of current. So you see that we have kind of a fight going on. The EMF is a force that is pushing current through the conductor, while resistance is a force. Now, this is not supposed to be done, but I just want you to understand. The resistance is a force that pushes the current back. It doesn't want the current to pass. So you see there is a war going on. This wants current to pass, this doesn't want current to pass, right? So it depends on the one that is stronger. If the voltage is stronger, the current is still going to pass, but you know that it's going to get weaker because the force that was used to push the current initially has been weakened by the force of the resistor pushing back. So after all is said and done, there is a current that will now flow. Now, this symbol that I've represented with A is called an ammeter. An ammeter is a device that measures electric current. So the current you're going to measure here is going to be the current that is flowing along this circuit. And what is Ohm's law saying? Ohm's law is saying that this current you're going to measure here is directly proportional on the voltage. It simply means that the current depends on the voltage, right? Because the bigger the force the voltage uses to push the current, the bigger current you measure. This is very simple. So as voltage is going up, the current is going up, but there must be a condition for this. This resistance or this resistor here must have a constant value. So it's not as if as you're increasing the voltage you're also adding more resistors. No, that would not make any sense. You have to have just this resistor here that is opposing the current. All right, so when you now have more force, imagine now, let me just use Newton force to just suggest something to you. This should not be done, but I just want you to understand. Let's say that this is pushing force current with 5 Newton, and let's say that this is resisting with 3 Newton, right? And let's just say that this is all forces. So I'm just going to use everything as forces, but this is not the way it should be done, just for you to have an intuitive understanding. Now, the current that will be measured by the ammeter, if you want to do the mass, is going to be 2 Newton, right? Because this is pushing with a 5 Newton resistor, will push out 3 Newton. 2 Newton of force is going to flow. If I increase this to 10, and I will leave the resistance at 3 Newton, you see that 8 Newton of current is going to flow. So This might not show the proportionality, but what you're seeing here is that as you increase the voltage, the current that will flow through will be increased, right? Actually, this should be 7. 10 minus 3 is 7, right? So you see that as the voltage is going up, current is going up, provided that we are leaving the resistance constant. So if you want to use it in the practical way they normally say it and all that, they now say that Ohm's law states that the current flowing through a metallic conductor, which is this wire, will be directly proportional to the voltage or the potential difference across its end, right? Provided that resistance and all the other physical conditions parameters are kept constant. So in this case now, it is my resistance that is constant. So if we apply mathematics, we're going to have that voltage is directly proportional to current. What would this imply? This is voltage is equal to a constant times current. But we're saying that let our constants be resistance. Now there are many constants. For instance, another constant can be temperature, because temperature can also affect resistance. Another constant can be the length. Another constant can be the nature of the material. All right. So there are many constants, but the one we have chosen to use as our constant is what? The resistance. All right. Resistance, and then we have I, which some textbooks like to write I before R. So this is Ohm's law. And it makes sense, right? Why we chose R as our constant is because of all these other constants that I've mentioned, that which is temperature, which is length, nature of substance, all these things, and area. Please, that's a very important one. The area. All of these affects directly the resistance. So when all these things are kept constant, automatically resistance will be kept constant, and then Ohm's law is going to hold.